Many people argue whether the globe model can make eclipse shadow from west to east or not. Let's make it clear once and for all. If we put all the data on the table transparently, in a way that everyone can understand, measure, and verify themselves, the answer is yes and no. Yes if and but no. Now the yes if first. Yes, eclipse shadow on the globe model can move from west to east only if Moon's orbital speed is faster than Earth's rotation speed. In heliocentric model, the Moon's orbital speed is twice as fast as the Earth's rotation speed. With this paradigm, for sure, the shadow will move from west to east. Let's make a model to make it easier to understand. The distance is not to scale. The Moon should be 30 Earth diameter away. If the Earth rotates 1,670 kilometers in 1 hour to your right, and the Moon orbits 3,683 kilometers to your right too, then you draw a straight line from Moon's diameter to the Earth. You will see the Moon's line is farther than the Earth's line. But of course, 3,683 kilometers is farther than 1,670 kilometers. You don't even need a model to understand. This is called linear speed. In this way, the eclipse shadow moves from west to east because the Moon is faster than the Earth. It's mathematically correct based on that assumptions and paradigm. But there's a big problem. It defies natural fact. If the Moon is faster than the Earth's rotation, you would see the Moon is setting to the east, the opposite of reality. Let's use mooncalc.org to make it easier. Find a place that has 90-degree elevation of the Moon. Imagine the Earth is moving 1,670 kilometers per hour, west to east to your right, and the Moon is moving 3,683 kilometers per hour to the same direction. Within 1 hour, you would see the Moon is more to your right, because it's faster and travels more distance than the Earth, right? Wrong! See what happens if you add time for 1 hour. Ooh, the Moon is going to your left, because the Earth is rotating faster. How come 1,670 kilometers per hour travels faster than 3,683 kilometers per hour? It's because the distance traveled by the Moon is 60 times longer than Earth's circumference. Now we're talking about the other kind of speed, the angular speed. Take bicycle wheel as an example of angular speed. The farthest part from the axis, the tire is moving faster than the axis, but actually it's the same angular speed. The farther from the axis, the faster it moves, but actually the same angular speed. Now, the Earth is rotating 360 degrees in 24 hours. It means 15 degrees per hour. If the Earth is moving 15 degrees counterclockwise to your right, and according to heliocentrism, the Sun is at rest, then you will see the Sun appears to be setting 15 degrees to your left. That's the angular speed of the Sun due to Earth's rotation, okay? While the Moon is orbiting the Earth 360 degrees in 29.5 days. Some people like to say 27.3 days, sidereal month, the Moon's position with respect to the stars. It's irrelevant, for we are counting the Moon's position with respect to the Earth, nothing to do with the stars. So we have to use synodic month, average 29.5 days. The angular speed of Moon's orbit is 1 per 24 hours divided by 29.5 days times 360 degrees equals to 0.51 degree per hour. That means when the Earth in an hour is rotating 15 degrees to your right, making the Sun appears to be setting to your left 15 degrees, the Moon is moving 0.51 degree to your right. That makes the Moon appears to be slower than the Earth's rotation. Let's go back to mooncalc.org. The Moon's elevation angle is 90 degrees. Then change the time to 1 hour later. Now you see the elevation is subtracted to 75.81 degree. 75 degree because the Earth is rotating 15 degree from previous 90 degree elevation. 0.81 degree is the Moon's traveling distance in 1 hour. Mooncalc is using different Moon distance on that day. Or perhaps they're using sidereal month. It's all mathematical assumptions. They don't even look to the sky. The Moon moves 0.5 degree against the Earth moves 15 degrees per hour. With these assumptions and paradigm, for sure, the eclipse shadow moves from east to west, the opposite of reality. So which one applies to the moon and the earth's speeds that creates eclipse shadow? Linear speed or angular speed? They will say it's the linear speed that matters.
The moon is orbiting about twice as fast as the Earth is spinning. So if we're looking down on the Earth and we're at the moon, we see the Earth spinning, but the moon is moving faster.
Wrong. Even if you're at the moon, in 1 hour, you would see the Earth is setting 0.51 degree to your left, while it's rotating 15 degrees to your right. Even if you're looking from the moon, the Earth's rotation is still faster. That means eclipse shadow in the globe model goes from east to west, the opposite of reality.